All right, so this is similar to the previous problem. I don't think it's going to take you, it's really the exact same question if you think about it. If you didn't watch that video, you may want to go back and watch it. But again, start with a diagram. We've got a ball, horizontal speed, all right, boom, off a table. It's coming off at a speed of 1.25 meters per second. And this is a 1 meter bench. Again, your numbers may vary, right? The question is, it's going to, of course, arc, land here. You're trying to find this value of x and also how long it's going to take. So again, you're going to identify x1, x2, x1, like this is 0, and this is x2. We don't know what x2 is, that they're asking that, right? But this, of course, is 0. Vx is this number, 1.25 meters per second. Ax, of course, is 0 because there's no acceleration in the x direction. T is question mark. And then y1. All right, so y1, it's starting at 1 meter, right? y2, he's going to land at 0 meters. Vy equals 0 because it's only a horizontal throwing. If we, some problems, next problem, in fact, we'll have a y where that changes. Acceleration is negative 9.8, and t is question mark. So the trick on this one is you're going to solve for t first in the y component. So you're going to have to find the time first, which is what they're asking anyways. And once you find the time, you're then going to plug the time in here and do this. Again, the equation you're going to use is just the master sort of equation. I'll write it in y's, but the same thing applies. So you can say y2 equals y1 plus vyt plus 1/2, and I'll say gt squared, or acceleration. Now, when you put this in x, of course, the acceleration is 0, et cetera, et cetera. So solve for t. There's a square root in this problem. And then once you solve for t, you plug it back, and that gives you the t, of course. But the t is equal to t. Remember, t doesn't change whether you're in x or y. And then you go to the t, you plug it back in, and you solve for x2. So you just replace this equation here with an x2 equation. All right, Houston, we don't have a problem.